Assalamu alaikum students. In today's class, we are going to learn about the number facts. So if we are going to talk about numbers, so we can have the whole numbers, natural numbers. So these are the terms or the number facts that you are learning from the very starting classes. So the first thing is integers. Okay. This is very important concept if we are going to talk about integer, because most of the time students used to be confused in this term that is basically integer. So integer for the integers, there is first condition that the integer must be a whole number. Okay, whole numbers basically starts from 0 and they will be like 0, 1, 2, 3 and so on, fine. But integers can be negative numbers as well, either negative either positive, like even you can represent the integers like this as well. 0 plus minus 1 plus minus 2 plus minus 3 and so on. Fine. So here what they gave, that integer is a positive or negative whole number. Okay, there is a condition for the integer that it must be a whole number. Like for example, if I have negative 0.5, this is not an integer, it's just a number. Fine, because this one is not a whole number. For integer, there is a condition that it must be a whole number. Either 0, 0 can also be the integer, or all the other whole numbers. Fine. So this is the concept about the integers. Next, natural numbers. So natural numbers basically that are also the whole number, but they will start from 1 directly, and 1, 2, 3, 4 in this way, so on. Fine. Whole numbers start basically from 0, 1, 2, 3, and they are also positive numbers. Okay, next is prime numbers. So prime numbers basically are the numbers that are having only two factors. One is the number 1 and the number itself. For example, the first prime number we have is 2. Then we have the prime number 3. Then we have 5. Then we have 7. Then we have 11 and so on. Fine. Now, some of the students might be thinking that why the prime number starts from 2, like why it's not coming starting from 1. The reason is that, like for example, if I'm going to make the factors of this number 2, the factor would be 1 and 2, because 1 is the factor of every number. Whatsoever the number you are choosing and you are writing the factors of that particular number, you are going to write the 1 first, because 1 is the factor of every number. Similarly, if we are going to talk about 3, the factors of 3 are 1 and 3. For 5, the factors are 1 and 5. For 7, the factors are 1 and 7. For 11, the factors are 1 and 11. Now you can check all of these numbers are having two factors. One is the number 1. Second is the number itself, like whatsoever we are talking about. But the number 1 is only have the one factor. That's why it can't be a prime number. It's not a prime number. 1 is not a prime number. So directly the prime numbers are going to be started from 2 and onward. Okay. So simply the prime number is a number that is having only two factors. One is the number itself and the number 1. Okay. So they gave some examples over here. Like there are the first 6 prime numbers they gave us over here. So accordingly, you can check it. Next is the concept about the multiples. You all know that multiples are basically the values we are getting according to the tables after multiplication, like 12 1 times, 12 2 times, 12 3 times, 12 4 times. These are all the multiples. Okay. And factors basically are the number that are going to divide the number exactly or completely. So that would be a factor. For example, the factors for the 12 are 1, like as I told you before, that 1 is the factor of every number. So we have the number 1 for the factors of 12, then we have 2, because 12 can be divisible, completely divisible by 2, then 3 as well, 4 as well, 6 as well, and the number 12 at the end, fine. So these are all the factors of the number 12. Similarly, we can take one another example. Let's say the number 15, and we want to write down the factors for the number 15. So the factors for the number 15 could be starting from the 1 again, because 1 is the factor of every number. Then 15 is divisible by 3. 15 is divisible by 5. 5 3 times 15. And also 15 is divisible by the number itself. So these are all the factors for the number 15. So next concept is the lowest common multiple, that is basically the LCM. So lowest common multiple, finding the lowest common multiple, there isn't any one particular method. There are 3 to 4 different methods that you can use. So they're saying that the lowest common multiple is the smallest multiple, like for example, we are comparing two numbers and we want to find out the LCM of these two numbers, so that will be the lowest multiple of these two numbers. That would be common in 10 and 12 as well. For example, if I'm going to find out the multiple for this number 10 and number 20, let's find out. First, I'm going to write down the multiples of 10. That would be 10 one times, 10 two times, 3 times, 4 times, and so on. But here, the lowest common multiple I'm going to get directly from the very start. So like 21 times would be 20, 2 times 40, 3 times 60, and so on. So here the LCM or the lowest common multiple is this 20. This is basically called the multiple method. This one, multiple method. Fine. This method is quite suitable when we have very small numbers and we can easily find out the LCM using these numbers. But sometimes if the numbers are a bit greater or complex, so we can move towards the other methods as well. So I will let you know side by side those methods as well. So LCM means the lowest common multiple. Okay, next is HCF. HCF means highest common factor. Like as in LCM, there was the concept about the multiples. Now, if we are going to talk about the HCF, there is a concept about the factors, okay? And multiples and factors, as we discussed already. So here we will be using the factors, fine? So, and this time we are going to use the highest common factor. Previously, we were using the lowest common multiple. For example, they are talking about the numbers 16 and 24. Let's see what could be the HCF for 16 and 24. So first we need to write down the factors for both 16 as well and 24 as well. Like first factor for 16 would be 1, as 1 is the factor of every number, then 2, then we are going to have 4. After this, we are going to have 8 and 16 itself. So these are all the factors for 16. If we would be talking about 24, we are having the factor 1, then 2, then 3, 4, 6, 8, 12, and number 24 itself. Okay. Now from this, we need to pick up the highest common factor. Highest common factor means like the number that is common in both of them, but that would be the highest one. So this is the number 8 that is common and the highest as well. That's why the HCF for this is 8, as they gave us already over here. So similarly, for finding the HCF, you can use another method as well. So in the exercise, I will be just going to tell you about all the other method that we are going to use that in LCM and HCF method. Fine. Right now, just you need to make up your mind that what is basically the LCM and what is the concept of HCF. Okay, next is non-prime integers greater than 1 can all be written uniquely as a product of the prime numbers. Like all the other numbers that are not basically the prime numbers, we can write them as the product of their prime numbers. For example, if we have 8, so what prime numbers or prime factors I can use? Like I know that 2 times this will give me 8. Okay, these are all the prime numbers. Like prime number starts from 2. So if any of the number is written as a product of its prime numbers, so we would be calling it like this process is going to be called as prime factorization. Fine. Similarly, if I'm going to take another example, let's say we have the number 12 and we want to write down the prime factors for the number 12. So I'm going to write down 2 times 2, 2 times 4, and 4 2 times. Okay, we need to multiply it with 3 here. Okay, for 3 times would be 12. In this way, 2 as well as 3, these are all the prime numbers. So we are using the prime numbers to multiply them, and these would be the factors for the number 12. And this is basically called prime factorization. Okay. For prime factorization, there is another method as well that we used to call division method. This as well is there. Like for example, I have the number 12. So to 6 times, always try to use like the smallest number to divide it with. And then further you can just go on. So to 3 times 6 and 3 1 times. In this way directly as well, you can get the prime factorizations or prime numbers. Okay. So here they gave the example of number 30, that these are the prime numbers or the factors that we can use to multiply to get the prime factorization for 30. Okay, next is the concept about the square number. So if we are going to multiply a number itself, so that would be called a square of the number. Like for example, if I have the number 5, I want to find out the square of this number. So I'm going to multiply the number itself, and that would be square of the number. Fine. So two numbers multiplying together, they will give you the square of the number. Next is the cube of the number. So in cube, like similar number is going to be multiply thrice. Fine. Like for example, if I'm going to find out the 5 cube, so this would be 5 times 5 times 5. Okay, so this is cube of the number. Okay, cube number. So similarly, other numbers can also be used. So next is the concept about the indices that are used as a neat way. Like sometimes we have so many numbers, like they are similar and they are multiplying again and again, again and again. So we can write it down neatly in this way, like we can show them in the form of indices. Okay, indices means in the form of power. Like how many times 2 is basically being multiplied? 1, 2, 3, 4, 5, 6. 2 is being multiplied itself 6 times, so we can write 2 raised to the power 6. So this is basically the indices form. Okay, here this is basically the power, and this is basically called the base. Okay, you can read it as 2 raised to the power 6. 2 to the power 6 in this way. So similarly, they have shown that 3 raised to the power 5, how we can represent it into the form of power. Like 3 needs to be multiplied 5 times together. So we will be reading it at 3 to the power 5. Okay, so this is the concept about the indices. Next concept is about the reciprocal of a number. Okay, if we are going to talk about reciprocal of a number, that means that, for example, if I have been given a number 4, so I want to take the reciprocal, so I'm going to write it down under 1. So I have taken the reciprocal. Reciprocal means that you need to invert the particular number. For example, if 4 is not having any number under it, we can represent 1. Fine. And reciprocal of the number will be 1 by 4. Similarly, if you have 2 by 3, reciprocal of the number will be 3 by 2. And similarly, any other number as well you can take. Or either for the reciprocal, we use to represent the numbers in this way as well. For example, if I have 5 and I want to take the reciprocal, I'm going to write it down as 1 by 5, or we can represent 5 inverse as well. Okay, this inverse is basically also showing us the reciprocal. What does that mean? Like for example, if I have this 1 by 5, and if 5, we would be checking there isn't any power, so we can represent 1. So when I'm going to take this power in the numerator, I can represent 5 negative 1. Okay, so this is showing me the negative sign over here, negative 1 power. So we can represent as 1 by 5 as well. Similarly, some other numbers as well. Like here they give the example of n. Like if n is written in the form of reciprocal, either we can write 1 by n, or either we can write n negative 1, because n over here is not having any power. We can represent 1. And when you are bringing this n power 1 in the numerator, your sign of the power would be changed. That would be negative. Okay. So reciprocal of the number is the result dividing by 1 of that number. So if you are dividing it by 1, then it means that you have taken the reciprocal of this number. So this is all related to the number facts. Next, they gave us that one example about the HCF and LCM of the number using the Venn diagram. This is also one of the way to find out the prime factorization, using the prime factorization to find out the HCF and LCM. Fine. So using only one single Venn diagram, we can find out both of the things like HCF as well and LCM as well. Here is one example. Let's discuss first this. Like they gave us the numbers 75 and 200, and we need to write down first of all the factors, prime factors. Okay. For writing down the prime factors for 75, for example, you can make this one in this way. So we can divide it by 3 first of all. 3 2 times would be 6, and 3 5 times would be 15. 5 5 times 25. 5 1 times 5. In this way, the prime factors we got for 75 are 3 5 5. Here we go. Next is the number 200. So here as well, we need to write down the prime factors for 200. So we can use 2 as well. 2 1 times, 2 5 times, along with that 0 would be as it is. 5 10 times, 2 5 times, 5 1 time. So you can rearrange them like 2 2 2 and 5 and 5. So here we got the prime factors. Next you need to make the Venn diagram in this way, like the two circles that would be overlapped each other, and the first number is 75, the next number is 200. So here you will be writing the numbers that are common in both of them, like 75 and 200. So what are the numbers that are common? We have 1 5 here and 1 5 this as well. So they wrote two numbers over here that are common in 75 and 200 factors, okay? Next, we need to write down the numbers that are remaining, that are not the like the common numbers. So 75 is having the number 3 that is remaining. And for 200, we have 2's that are remaining over here. So here we got all the 2's over here. So after that, when we are going to find out the HCF, as HCF is the highest common factor, we are talking about the common factors. So these are already the factors that we wrote over here. So you can directly take the common numbers that you wrote over here, multiply them, and that would be your HCF. 5 times 25. Okay. Next, if we are going to talk about the LCM, in LCM, basically, what we need to do, we need to write the common factor and then we will multiply those common factor by non-common factors as well. Like what are the common factors? We got 5 times 5 and the non-common factor remaining are 3, 2, 2, 2. All the non-common factors would also be included in LCM. So then you can multiply these all numbers and we got 600, okay? So this is the way to find out the HCF and LCM using the Venn diagram. So hope so this method is clear to you. According to these all concepts about the number facts, we need to start the exercise 1.3a. Okay, students, starting exercise 13.a, in the first question, they're saying that you need to determine which of the following are the prime numbers. So from these all, we need to pick up the numbers that are basically the prime numbers. So prime numbers are only have two factors. Okay, let me discuss that again with you. Prime numbers are only have two factors. Okay, one is the number 1 and the number itself. If all of these numbers from these, the numbers that are having only two factors, so we are going to take them as a prime number, okay? So as I told you at the very start, like 3 and 11, they would be prime factors or prime numbers. So 15 is not a prime number. Why? Because 15 is going to have the factors like 1, 3, 5, and 15 itself. So like more than two factors it's having. That's why this is not a prime number. Okay. Next is the number 19. Yes, number 19 is not coming in any other table. So we can take number 19 as well. 21 as well is not a prime number. 23 we can take. 27 is not. 29 we can take. 31 as well. Like 31 is also not coming in any other table. So other than that, a 1 and the number itself. Okay, so 37 as well. 39 would be divisible by 3 and some others number as well. 47 we can take as a prime number. Next, 59, yes. 51 is not a prime number because it can be divisible by 3. Okay, 59 as well is a prime number. 61 as well is a prime number. 67 as well is a prime number. And 72 is not a prime number, it's an even number. 73 would be a prime number. 87 is not a prime number that can be divisible by any number. And then we have 99, that is also not a prime number. Okay, so in this way, these numbers can be find out like if the number is a prime number or not. You need to just simply divide it by some numbers, check if that is not divisible by any number. So you can just say that this is basically a prime number, okay? So next, second one part, they're saying write down the first 5 multiples of all these numbers. So if you know the table, so you can easily work out the 5 multiples. Like for example, for question number 2, we have a part for writing down the first 5 multiples. So for 4, We have for 1 times, for 2 times 8, for 3 times 12, for 4 times 16, for 5 times 20. Next, as we have number 6. So the multiples for the 6 are 6 1 times, 6 2 times, 6 3 times, and then 6 4 times, and then 6 5 times 30. Okay. In this way, similarly, you need to write down for 10 as well, multiple for 10 and 11. They are easy. Next, we need to pick up the numbers or the multiples for the number 20 as well. So 21 times, 22 times 40, 3 times 60, 4 times 80, 5 times 100. Okay, these are all the multiples. First 5 multiples of all these numbers, 10 and 11, you can pick it up. Next, we have question number 3, and in this they're saying write down the first 6 multiples of 4 and 6 and write down the first 2 common multiples of 4 and 6. Okay, multiples and 4 of 4 and 6 we need to basically write down for question number 3. So multiples of the number 4 and multiples of the number 6. Just for 6 multiples we are going to write down. As we wrote the multiples already, you can pick up from those as well. 4, 8, 12, 16, 20, 24. For 6, we have 6, 12, 18, 24, 30, 36. So 2 common multiples we need to pick up. So first common multiple is the number 12. Second common multiple is the number 24. So we got the 2 common multiples. One is the number 12 and the second one is the number 24. Okay, these two are the common multiples. Similarly, they gave that write down the first 6 multiples of 3 and 5 and what is the lowest common multiple of this. Like we need to find out basically the LCM for question number 4 over here. So first of all, we need to write down the multiples for 3 and 5. And first 6 multiples we are going to write down like 3 1 times, 3 2 times 6, 3 3 times 9, 3 4 times 12, 3 5 times 15, 3 6 times 18. Okay. Similarly for 5, 5, 10, 15, 20, 25, 30. So for this, as we need to pick up the lowest common multiple, LCM. So which one is the multiple that is the lowest common multiple? It's the number 15 we have. So this is the LCM for the number 3 and the number 5 as well. Hope so they are getting clear. Next is the part number 5 in which we need to write down the factors. Like previously, we were dealing with the multiples and accordingly we were finding the LCM. But now we are going to write down the factors and accordingly we will be finding out the HCF. Okay, let's go on with the part number 5. We need to write down the factors. Let's say for the 6th one, the number 6. As I told you earlier, that the numbers, if we are going to write down the factors of the number, we need to write down 1 first, okay, as the number 1 is the factor of all the numbers, okay? Then 6 is divisible by 2, 6 is divisible by 3, and 6 is divisible by itself. So these are all the factors, okay? Next is the number 9. So 1 is the factor of every number, then 9 is divisible by 3, and 9 is divisible by the number itself. Then we have the number 10 for the part number C. So writing the factors for the number 10, we have number like 1, that is basically the factor of every number. Then we have 2, 10 is divisible by 2, it's divisible by 5, and it's divisible by the number itself, okay? Similarly, for the D part, we need to take the number 15. Let's find out the factors. We are going to have the number 1 as it's the factor of every number. Then it's divisible by 3, by 5, by the number 10 as well. Next is the number E. It's having 24. We need to write down the factors for the number 24. So 1 is the factor of every number. Then it's divisible by 2. It's divisible by 3 as well. And is divisible by 4 as well, is divisible by 6 as well, 8 as well, 12 as well, and 24 itself, as we wrote previously as well. Okay, next is F part, and this is having the number 32, and we need to write down the factors for the number 32 as well. So again, 1 is the number, 1 is the factor of every number. So after writing 1 as the factor of this third, and 32 is an even number, so obviously this will be divisible by 2, but it's not divisible by 3. Next we have it 4. 32 will be divisible by 4. And 4 8 times is 32, so 8 is also there. 16 2 times 32, and 32 itself. So these are all the factors of a number. Okay. So accordingly, next needs to go on with part number 6, and here they're asking that you needs to find out either 263 is a prime number or not. So for finding out for this greater number, we need to divide it by some numbers, and then we will see either it's a prime number or not. And they're saying by how many numbers do you need to divide 263 so that you can find it out that either it's a prime number or not. So at the start, we can start it from the very small numbers. This is part number 6, and we need to find out either 263 is a prime number or not. So for this, let's check that either it's divisible by 2. So it's not divisible by 2 because it's having 3 at the end. So directly we can start it by 3. Let's see if it can be divisible. So by 3 is as well, it's not completely divisible, but like when we are finding a number, if it's a prime number or not, we need to divide it by a number that must be exactly divisible. Like that must be a factor of that number, but 3 is not, okay? Next, if it would be like this is an odd number, no? So we can use the odd numbers to divide them with, or prime numbers. So this is also not divisible by 5. Next, we can divide it by 7. Let's see. I'm using the calculator, and from the calculator, you can easily check like for 263, dividing by 7 is giving us 37.5 something. So it's not divisible by 7 as well. So let's see if it can be divisible by 11. No, it's not divisible by 11 as well. And this, let's see if it can be divisible by 13. So it's not divisible by 13 as well. It means that, yes, 263 is a prime number because it's not divisible by any of the odd number over here. Okay. Then the next number is 527, and we need to check, is this a prime number or not? So for this as well, again, we will see that after dividing by some numbers, is it divisible or not? So 527, let's find out the factors that are exactly divisible. Okay, as this is 527, at the end we have 7, so let's divide it first by 3. 527 dividing by 3. It's not divisible. Let's find out 527 dividing by 7. It's not divisible. Okay, like we can check by some other numbers as well. That could be some greater number, but let's find out by 9. So dividing 527 by 9, this is also not divisible, completely divisible. So as these are not, all of these numbers are not divisible, let's find out with some greater numbers like 11 or 17 we can use. Even if we are getting any one number as well, so that means that this is not a prime number. Okay, from this it's not exactly divisible. So 527 dividing by 17 is, yeah, this is giving me 31 answer. So this is divisible exactly by the number 17. It means that this number 527 is not a prime number. Okay, so for finding out, like for some greater numbers, that either they are prime number or not, you need to divide it by divide all of these by some numbers, and then you can check carefully that either they are divisible or not. Okay, so hope so this one is clear to you all. So from the next question and onward, we will start from the next lecture. So till that, Allah Hafiz.